Let's start off by labeling this diagram that we have. So I want us to focus our attention on these black and red lines right here. What I'm trying to show you is that this angle and this angle are the same as this angle right here. We're going to need this angle later on when we're solving for our height over here. The next thing we're going to do is we're going to create this triangle right here. This angle will be denoted by the symbol phi, and we spell that with PHI, so the symbol phi. This angle right here is going to be double whatever theta is equal to. The next thing we need to do is we're going to solve for phi, and we get that phi is equal to 40 degrees. Later on, we're going to be using this angle. The next thing I want to do is I want to label this diagram just a little bit more. This right here is going to be symbolized by the letter B. Will represent this length right here with the letter C, and our height will represent that with the letter H. And just for future clarification, this right here is the direct path, and this right here is the reflected path. The next thing I want us to do is focus our attention on these black triangles right here. What we're trying to do is we're trying to solve for B and C. So using our trigonometry, we know that C is equal to H times sine theta, and we know that B is equal to C times sine of phi. What we're going to do next is we're going to take this right here and we're going to make a substitution for the C value right here so that we get B is equal to H times sine theta times sine of phi. The next thing we need to do is recall what the destructive interference formula really is. It's simply the path difference, and we set that equal to m, and m is just an integer value, plus 1/2 times lambda. Now, what exactly is the path difference? Recall that I was talking about this being the direct path and this right here being the reflected path. So the next thing we need to do is figure out, is the reflected path larger or is the direct path larger in terms of length? Now, it turns out that the reflected path is going to be larger in length, and the reason being is that it takes more time for a reflected path to reach this point right here. The direct path takes a shorter distance, hence why we call it a direct path. So that's going to be C minus B, and we're going to set that equal to m plus 1/2 times lambda. So what we're going to do now is we're going to make our substitution for the letters B and C so that we get that the path difference is equal to H times sine theta minus H times sine theta times sine of phi is equal to 0 plus 1/2 times lambda. The reason we're going to make this 0 is, one, we want to make this a more simplified equation, and the second reason is that the question is asking for the first minimum of destructive interference. The first minimum is going to occur at 1/2. And for that to be true, this integer value for m would have to be 0. The next thing we're going to do is we're going to do some algebraic kung fu manipulation, and we're going to focus our attention on this term right here. What we'll do first is we'll pull out the sine theta. The next thing we're going to do is we'll divide this entire term by sine theta so that we get h over sine theta minus h times sine of phi divided by sine theta. The last thing we'll do is we'll factor out the h over sine theta so that we get h divided by sine theta is equal to 1 minus sine of phi, and we set that equal to, so we just take this right here and we get lambda over 2. The next thing we'll do is we'll rearrange this equation so that we solve for h, and h is equal to lambda times sine theta divided by 2 times 1 minus sine of phi. Lastly, we'll just take the given values and we'll plug them in so that we get a height of 148 meters.